sp hybridization. In sp hybridization, one s and one p orbital of an atom mix up together and form two hybrid orbitals of equal energy and identical shape. The orbitals thus obtained are called sp hybrid orbitals. Each sp hybrid orbital has 50% s character and 50% p character. Fill in the blank question. These orbitals are oriented along a particular axis at an angle of 180 with an atom. Fill in the blank question again or choose the correct answer. Then, with the atom in the middle. Therefore, a molecule involving this type of hybridization is linear in shape. Another fill in the blank question or choose the correct answer. The shape of the molecule is very important. It is linear. Let us take an example: acetylene, C2H2. Follow the same rules. The electronic configuration of two carbon atoms, that is C2H2, separately write all the steps. The ground state 1s2, 2s2, 2p2. Then in the excited state 2s2 gets unpaired and that electron goes to the pz orbital. Hybridized state of all the four unpaired orbitals of s and 3p, we take only 1s and 1p. The other two p orbitals remain as such. That is, py and pz are known as unhybridized orbitals or pure orbitals. First carbon atom in the hybridized state, that is 1s2 remain as such, two hybrid orbitals, each one is known as sp hybridized and two unhybridized orbital. Second carbon atom also follow the same pattern, ground state 1s2, 2s2, 2p2 and the excited state 1s2, 2s1, 2px1, 2py1, 2pz1. Now we are taking only 1s and 1p known as sp hybridized. And the hybridized state we get two sp hybridized orbital and two unhybridized orbital. Now is the most important point, the diagram. Therefore, please refer the textbook how the diagram and draw this diagram in your notebook. Let me explain. These are the two carbon atom. One carbon atom and this is the second carbon atom. Each carbon atom, the 2sp hybrid orbital. This is the 2sp hybrid orbitals of this carbon atom. These two hybrid orbitals, one sp hybrid orbital overlap with another carbon atom head-on overlap, resulting in the formation of a sigma bond. Therefore, carbon sigma bond, that is sp overlapping with another sp of the second carbon atom. Now there is another sp hybrid orbital for each carbon atom, that is sp hybrid orbital overlap with the hydrogen and that is head-on overlap, resulting in the formation of a sigma bond. Therefore, carbon hydrogen a sigma bond. This carbon also, the other sp hybrid orbital overlap with another hydrogen atom head-on, forming a sigma bond. Therefore, carbon hydrogen another sigma bond. Now is the most important factors. Two unhybridized orbitals, that is actually py and pz for both the carbon atom. That is here also py, pz is remaining. Consider these are the p and this is pz. This is py and this is pz. That will undergo sidewise overlap. Let us take first py. Py undergoes overlapping, that is sidewise overlap, resulting in the formation of a carbon-carbon pi bond. That is, any sidewise overlap, it always result in a pi bond. Therefore, py resulted in a pi bond. Next one, pz, sidewise overlap, resulting in the formation of carbon-carbon pi bond. These are all the bond formed. For the examination, the question model is that explain the type of hybridization in acetylene and explain how many sigma bonds and how many pi bonds with the help of the diagram. Therefore, now let us summarize the point here. Each carbon atom uses its one sp hybrid orbital cc sigma bond and the other to form, that is carbon-carbon sigma bond and a carbon-hydrogen sigma bond. Thus one carbon-carbon sigma bond and two carbon-hydrogen sigma bonds. That means carbon-carbon sigma bond, carbon-hydrogen bond, carbon-hydrogen bond. That is two carbon-hydrogen bond and carbon-carbon sigma bond. At this stage, each carbon is left with two pure p orbitals. These two p orbitals, one carbon overlap sidewise, important, with the corresponding orbitals of the other carbon atom, resulting in the formation of two carbon-carbon pi bonds. If the carbon-carbon sigma bond is formed along the x-axis, the pure 2p orbital left on and each carbon atom is 2py and 2pz. In this case, two carbon-carbon pi bond will be formed by the sidewise overlap of 2py, that is one pi bond, 2pz, another pi bond. Each carbon-carbon pi bond in acetylene is made up of two clouds, one lying above and the other below the plane. That means because of the dumbbell shape, see, on the top there is a cloud and bottom there is another cloud, but bond is only one pi bond. Now, each carbon-carbon pi bond in acetylene made up of two clouds, one lying above and the other below the plane, containing the two carbon atom. An acetylene molecule consists of 5 covalent bonds. Carbon-hydrogen sigma bond 2, carbon-carbon sigma bond 1, carbon-carbon pi bond 2. The two carbon atoms are thus linked together by 3 bonds, that is triple bond. This is why acetylene is represented as CH, C triple bond and CH. The triple bond between carbon-carbon bond length in it is 120 picometer and hydrogen-carbon-hydrogen bond angle is 180 degree. And thus acetylene is a linear molecule. These 3 points are very important for each molecule. Any molecule regarding the hybridization, you have to say the bond angle, you have to say the shape of the molecule and say the bond, sigma bond, pi bond, etc. It is to be noted that the double bond in ethylene, CH2 double bond CH2, is made up of one sigma bond and one pi bond, while the triple bond of acetylene, CH triple bond CH, is made up of one sigma bond and two pi bond. Distinguish acetylene and ethylene in the case of sigma bonds and pi bonds. That is normal, an important question. Therefore, please follow all the steps in order to write any hybridization, whether it is sp, whether it is sp2 or whether it is sp3. Write the electronic configuration, ground state, excited state, hybridized state and the diagram and the sigma bond and the pi bonds.